Welcome back to the channel. It's your boy Finay. Today I'm gonna be talking about sorting algorithm. Okay, those are very important questions when it comes to tech and computers, and it's very good to have that knowledge. Okay, what I'm gonna do is I'm gonna explain it in a way like you guys can understand using just mathematics. Okay, and that's it. Like it's just pure math, no coding yet. I'm planning on making another video to show you the code using C++, but I just want you to understand the logic that is behind the sorting algorithms. Okay, and we're gonna do the public sort and then the selection sort, and maybe next video I'll do like the coding part of it while doing the explanation for the time complexity and space. Okay, but right now we're just gonna do the math. The math, keep it simple, and then you guys can move on to the next video, and that's it. So let's just jump right into it. Let's go. So let's start with the sorting algorithm, right? So what I'm gonna do here, I'm gonna say the bubble sort. Okay, don't mind my handwriting. Bubble sort. Okay. What we're gonna create here is the idea of like numbers. Okay, we're gonna have four numbers. Okay, so we're gonna keep it very simple. So we're gonna have like let's think about 1, 2, 3, 4. We want to make sure our bubble sort is doing this for us. Okay, when a number is not in place. So we're gonna have, let's say we're gonna have four, maybe two, one, and then three. So that is going to look like for our bubble sort. Okay. So let me rearrange this to make it look better. Okay. So we got four, two, right, one, and then three. All right. Bubble sort is gonna do what? Bubble sort is gonna compare each of these index. Okay, which is gonna be 0, 1, 2, and then 3. So I'm gonna compare 4 to 2. All right. Is 4 greater than 2? Yes, it is. Therefore, what? Therefore, 2 is going to be replaced. Okay, so now it's going to be what? It's going to be 2, 4, and we're going to continue 1, then 3. Now, as you guys can see, 4 is greater than 1. So we're going to push it, right? We're going to say, ha, 4 is greater than 1. So now we're going to continue. We're going to say 2, 1, 4, 3. But now we also have a problem. You can see that now we have to check the 2 because now 2 is greater than 1. And this is not making sense because now we have to check it. Remember, we're going this way. Okay? So now we have to do, okay, 2 is greater than 1. Yes. So therefore it's going to be 1, 2, 4, and then 3. Okay? Now what are we looking at? We're going to go, okay, that's good, right? 1 is smaller than 2. Therefore, what? 2 is smaller than 4. But is 4 smaller than 3? No. So we're going to switch it. We're going to be doing, like now, 4 is not smaller than 3. Therefore, we're going to be having 1, 2, 3, 4. And that's how you do the math of bubble sort. Okay? Not the best one, but it will get you there. But imagine if you had like a big sum of number, it would take you too long to go through it. I found this on the web. Okay. For how to do the math of Bulbasaur, not the best. I don't know why Siri listen to me right now, but hey. But yeah, that's the idea of bubble sort. Okay. Let's jump right into what selection sort looks like. Okay. Let's maybe put higher number. Okay. So we're gonna call selection sort algorithm here. Selection sort. Maybe let's go for multiple digits this time around. We're gonna do 7. Let's go 7. Okay. Maybe do 5 here. Okay. And we're gonna have, let's put 3 because we don't want them to be in place. And we're gonna have maybe 4 here. Okay, let's do 4. And I don't like this. And 1, and then 2. Okay. So all of which have indexes. So we're gonna have 1, 2, 3, 4, 3, 1, 4, 5, 3, 4, 5. Okay, I'm missing a number here. We're gonna put 6. Okay, I can see it. Oh, you guys cannot see it. Okay. So it's gonna be 7, 5, 3, and then over here we're gonna have the 6. Okay, I know you guys can see it. And then I'm gonna have index 5 and then 6. Okay. What I like about putting indexes is like if I was missing a number, I would know because it go from 0 to 6. So if I was missing a number, I would know. Okay. So let's go. From there on, we're gonna say, hey, let's create a minimum and then a temporary to hold those values. Okay. So we're gonna have a section that's gonna have our minimum value and our temporary value. Okay. So over here we're gonna have our temp, right? And we're just gonna hold our temporary value. So right now, selection sort is doing is going 7, 5, 3, 4, 1. 1 is the minimum value over all of this. Okay? So right now, 1 is the minimum value. Does that make sense? So we're gonna do all right. Minimum value is 1. Well, index is index 4. So therefore now the temporary value is gonna be 7. Okay? Does that make sense? So the temporary value is gonna be 7. So we're gonna have now 1 has been sorted, right? So 1, this is gonna be the new outlook of our array, okay? Or some people, some of the Python tech guys might call it this, okay? Let's not dive into this. But let's continue. So we're gonna have 1, okay? Still 5, okay? Still 3, right? At this point, we're gonna have what's going on here? We're gonna have 4, okay? We're gonna have, since I just replaced it now, right? I just replaced this value here by I'm gonna replace it by the temporary value, which is 7, okay? And then we're gonna have 7. Does that make sense? Because now we're using the index as like our pinpoint, okay? Since I replaced it, this has been sorted. Now the temporary value have to be replaced by the current index, and then we're gonna continue here, and we're gonna have 2, right? And then it's gonna be 6, okay? Not enough space. You guys understand, okay? So let's continue. Let's go down a little bit. I have more space. Now 1 has been sorted, okay? I'm gonna put this as an to say, hey, 1 has been currently sorted, okay? This one sorted. Now we're gonna go look through the entire array from the part that's unsorted, which is this part, okay? Unsorted. Yes, we're gonna look. What is the minimum value? We're gonna have the minimum value at 2. Okay. So now we're gonna put minimum value is 2. Okay. We have this index now, which is index 1. And then the index of value 2 is still gonna be 5. Okay. So we're gonna replace that. We're gonna be 1. We're gonna have 1. Okay. Which is already sorted. And we're also gonna have 2. All right. Which is now becoming after 1. So now this has been sorted. We have 1, index 1, and then index 0 and index 1. Okay? So let's continue here. Now we'll have 3, obviously, right? We're going to have, excuse me, we're going to have 3, and then we're going to have 4, you feel me? 4, 7, yes? And then over here, instead of having the 2, we're going to have 5, because now 5 is what in the temporary value, okay? Which is going to be replaced in this index. And then we're going to have 6, okay? Does that make sense? Since we look now, we're going to say, hey, 3 has been sorted now. We look at 3. 3 is a minimum value now. Sorted. 4 is a minimum value. You can see it. You already see it. You don't have to test this anymore. Like, you see this has been sorted, right? So you can just skip most of this new sorted element. You don't have to go back and oversee it. We can already see, hey, 3 and 4, now it's sorted. Boom. So we have 1, already sorted, 2, 3, 4. Some teachers might ask you, some professors might ask you like to show them proof of it. That would be your prerogative, okay, to do it and then show it like with either like minimum and temporary value. If I'm a professor, I would like to see it. But for this purpose right here, because we're trying to do this very quickly, just understand the first part I just explained. That way you can show it with using temporary values, okay? So right now, this part right here, sorted. Unsorted element, we have 7, right? 5, okay? 6. Does that make sense? Now, we're still gonna look. We're gonna be like, wow, what is the minimum value here? The minimum value is going to be what? 5. Okay? And then now the temporary value is going to be 7. So it's going to be 5, right? And then 7, yes. And then 6. Okay? Now, this sorted. Minimum value is going to be 6 here. And then now the temporary value is also going to be 7. So we're going to have 6 going to 7. Okay? And then because now 7 is the maximum value, this entire thing has been sorted. This is what selection sort looks like. Okay, 2, 3, 4, and then 5. All right. So this is selection sort. Fairly simple. No explanation needed. Okay. It's very like straightforward. Okay. Like the math is just straightforward. You have to understand it as like, hey, it's going this way. Okay. Let me understand this. This has been sorted. Let me continue the section that's unsorted. This is what I like about selection sort. Was like, this part has been sorted. I don't even have to look at it anymore. It's already bypassed. And that's how the code is also going to analyze it. It's like, this has been sorted. Move on. Okay. So then you're going to go to the part that's unsorted. All right. So some people might do it differently than me. Right. Me, I like to go about it like in a mathematical way. So that's the best way I can explain it. Okay. That's the best way, easiest way for somebody to, if you have an exam, like, you're trying to like not take too long in it. That's the fastest way you could go about this. Like, bop, 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 bop. And then what's crazy is like over here, if I'm doing this, I could just be point, because I would know these are already sorted. I don't have to rewrite them, right? I already know that, and it's just gonna drop down, right? Make sense? So yeah, this is what selection sort and bubble sort looks like. Okay, and my advice will have to be like, when you get a chance, work on like having more elements in your array, more numbers in your array, and that way like you can analyze it and oversee like what's actually going on. So thanks so much for watching. Stay tuned. Don't forget to like and subscribe. And as I said before, like if you learn something new in this channel, man, if you're always learning something new, don't forget to like and subscribe.